Okay, hi. Now in this video we're going to speak about water treatment. So in the last two videos we spoke about hard water, what it is and how we deal with it. In this case we're talking about clean water versus dirty water, okay? There is a massive difference between those two. So of course, most of us probably take for granted, the fact that we have clean drinking water straight out of a tap. This is not the case all around the world. In a lot of places in the world, their water is contaminated. It is dangerous for them to drink, but they have to drink it. We get water out of a tap. It is clean for us, and that is a massive luxury. Okay, so first of all, where do we get our water from? Well, the water source will tell us how many steps we need to go about in order to clean the water. Now, one place we can get it from is a borehole, okay? Now, boreholes are basically holes in the ground which have been either naturally or artificially dug through the rock, okay? And now when water comes up through rocks, it goes through natural purification. So it's already pretty clean, okay? Now, this isn't the scientific term. It's very clean when it comes through the rock. There only needs to be a bit more done to it. So the only thing that the rocks won't get rid of are bacteria. So we add chlorine, okay, in order to sterilize it, which in real terms is killing the bacteria. Okay, I'll just put here in brackets, sterilize. Okay, so that's what we want to do to water that comes from a borehole. It does not need many steps in order to clean it before it's safe for us to drink. Now, the other more common place that we will obtain our water from are rivers, okay, rivers and reservoirs. Okay, these contain large amounts of water, and obviously they're an obvious place for us to obtain the water from. Well, you might be thinking, well, what about the ocean? Surely that'd be even better because there's so much of it. Yes, true, but it is all salt water in the ocean, which means that there are a lot more steps in order to purify that water. We can do it, but the time and money investment in order to do that makes it not as good as getting water from other places. Okay, now in your book, it then goes on to explain, other ways that we purify water, and then it comes onto a diagram showing how we do it from the rivers and reservoirs. I think it probably makes sense to go into that straight away. Okay, now I'm not an artist, so I'm going to try and explain this more schematically rather than drawing pretty diagrams. But the first step, okay, is you start off with a body of water. Okay, with a body of water. This might be a river, it might be a reservoir, okay, either or, it's the same thing. Now, first off, we don't know what's in the water, okay, there might be large objects in the water, which obviously we don't want in our drinking water. So, this water travels through some sort of system, and we're going to put cages in place, okay. Now, this is obviously a simplified diagram, but you've got cages in place, okay, so these will trap large objects, okay, that could be branches, it could be even leaves, and so on. Just large solid objects that we don't want to be drinking or having in our drinking water. So it's important that these bars, okay, so these bars here in the cage, they are close together. Sorry if you can't read my handwriting. They are close together. Okay, and then the water will arrive, okay, at a second container. Okay, obviously this absolutely depends on how the people want to build all these containers, on how it's going to actually look, but this is just a simple diagram. The second container, okay, is what is known as a settlement tank. Okay, so I'm going to write number 2. This is a settlement tank. And what that means is that sand and soil in this container are going to settle out. Because they are solid, but they're really small, so the cages have missed them. Okay, I'm just going to draw them brown. Obviously, sand might be more yellow. But the sand and the soil, okay, will settle out in the bottom of the container. Blah, blah, blah. Like so. And so this is removing smaller solid particles. Okay, we then have a third container, okay? A third container. Now, it doesn't have to be vertical like this, but this is so you can see everything all on the same page. You have a third container, okay, and here we add aluminium sulfate, and lime, okay. That's not the fruit lime, okay, that's lime when we're talking about salts of calcium. Okay, but adding those persuades other small particles which aren't soil or sand, okay, which are harder to get rid of. It persuades them to clump together. So I'm just going to draw them darker brown than the ones above. Okay, so it causes those solid particles, okay, to clump together. We can just label these dirt in general, okay. It's obviously loads of different compounds together, but it's dirt, clumps together, and then these are dumped in landfill and they form mud, okay. So it is actually dirt which will form mud later on. Okay, so that's all good. Oh, sorry, I didn't label that, so that's number 3 there. That's all good, but it's not 100% effective, okay. So we go to a 4th tank. Right, and where some of the dirt in the previous part, in number 3, maybe that they weren't all removed, some of them still remained. We want to persuade all of them to leave and form clear water. So at the moment this water is probably still a little bit murky because it's got some dirt in there or whatever. Okay, this tank contains really fine sand, okay, and this acts as a filter. So I'm going to call this a fine just means the particles are really small, fine sand filter. Okay, and so when the water flows through here, okay, it's going to leave this tank and flow into another one. Now the water is going to be clear, okay, because all of the solids have been removed by all of these processes. Large solids at the start, and then smaller, and then the remaining in number 4. So in number 5, we've got clear water. Hooray! However, obviously that water is not necessarily safe to drink because it might contain bacteria. Okay, so in tank 5, we are going to add chlorine. Just going to draw that in a different colour. We're going to add chlorine. Now, not loads of chlorine because our drinking water is nothing like things like a swimming pool. Okay, you don't want to drink loads of that because too much chlorine is bad for us as well. Okay, but we're going to add chlorine to kill bacteria and obviously any other microorganisms that are going to do us any harm. Now, once that is done, hooray, we have drinking water. Okay, there is one last step though. So this is a pipe going out to all of us for us to happily drink it. But as it's going out, okay, there is one more step. We need to check the pH. Okay, so we check the pH of the water. Now, if the pH is neutral, okay, so it's close to pH 7, we are fine with that. We're like, okay, we're going to drink that. That's cool. If the pH is around pH 5 or lower, or it's 8 or above, okay, then we probably have a problem because it's too acidic, it's too alkaline. And so if pH is not correct, so it's not as close to neutral as we want it, there's obviously a little bit of leeway, then chemicals added. And those chemicals are obviously going to be acids or bases, because if our water is too acidic, we're going to add some alkaline, neutralize it. And that produces water, and it causes the pH to become closer to 7. Okay, so if pH is not correct, then chemicals are added. I'll put in brackets here, acid or base, so that you understand fully. Okay, and then after that, the water leaves and it's safe to drink. Okay, so after that, the water is safe to drink. Right, now I thought it was best to do it in that order because I think the book has got it a little bit backwards, but there are a couple of other things that you need to know. So first of all, you probably have seen things like Brita filters. We are going to collectively call those filter jugs because I'm not advertising anyone's brands here, okay? Right, so filter jugs. You'll have a jug, okay, and it will have a cartridge at the top, right? Now this is a completely simplified diagram. There might be this in there as well. So you pour the water in the top, it goes into here, into the cartridge, okay, and then it will filter out into the jug, and all of this good stuff here is our drinking water. Okay, so this here is our drinking water. Whoa, that's awful handwriting. There we go. Now I'm going to write this in a different colour just for the sake of variety. So the cartridge is known as the filter cartridge. Okay, and usually it contains the following elements. It contains activated carbon. Okay, by activated we just mean it's more reactive than normal carbon. Okay, so activated carbon, ion exchange resin. Okay, and if you've watched the previous videos on hard water, you know what ion exchange is now. Okay, so an ion exchange resin and silver. Now, each have their own jobs, so we're going to zoom in here like so. So, the carbon, okay, the carbon is there to reduce the level of chlorine, reduce chlorine level, okay, as well as other impurities, okay, so other, I'm just going to say others, but it's other impurities, including things like pesticides, which can find their way into the water supply and so on. Now you can probably guess what ion exchange is for from the previous videos as well. Ion exchange is involved in removing the metal ions that we don't want. So we're going to remove things like calcium, okay, things like calcium, magnesium, I'm just going to use the shorthand, magnesium, lead, which is Pb, okay, so I should probably really write lead, because that's not a really obvious one. Okay, so lead and other metals as well, such as copper, aluminium, and so on. Okay, and finally, silver is there to stop the filter itself being contaminated. So it prevents bacterial growth. Bacterial growth. Now remember that bacteria will grow in water, okay? Just like we need water to survive, so do bacteria. Now if you have a filter cartridge, which you're using on a regular basis, it's constantly being surrounded by water. That means bacteria could technically grow in there, okay? And having silver in there, silver is antibacterial. Bacteria do not like silver, okay? But we put that silver in there to stop them growing. Okay. Finally, because of all that stuff that we put in there, okay, let's just zoom out, there we go. Because of all the stuff we need to put in there, the filter needs to be changed every few weeks. That's because, obviously, for one, the ion exchange resin is going to be used up because the ions that you're exchanging are going to be gone. And we need to make sure we've got enough active carbon and so on. Okay, and finally, all of this stuff we've been talking about is to make drinking water. So, drinking water is the goal. Now, is drinking water pure? Well, I'm going to tell you straight away, no, it's not normally. Okay, pure water could be drinking water, but water which is safe to drink normally isn't pure. Now, pure water, okay, that means nothing else in there. So nothing else other than water. Okay, drinking water, now this can contain other substances other than water, so long as those substances do not make the water dangerous, and it means that we can still safely drink it. So I'm not going to write all that out, but drinking water, when we drink water, it contains other substances. It's not pure water that we're drinking, okay? If you think of mineral water, which you buy in a bottle, the word mineral means it's got ions in there, okay? So it's not pure water, it contains minerals. But it is still completely safe for us to drink, and that is what we're trying to achieve when we're producing drinking water. Pure water has another term, we can call it distilled. Okay, distilled water. Now, distilled water is used a lot in chemistry, in labs. Okay, so it's used in labs. And you can guess why. Because if you use distilled water, it means that there's no chance of any of those substances dissolved in water actually reacting and messing up a reaction. If we know that the water we're using in a lab is only water and nothing else, it means that we know exactly what's going on. If we added mineral water as a solvent, maybe the metal ions inside the mineral water are messing about with our reaction, okay, and that's something that you don't want. So that's why in labs we use distilled water. Now, distilled water is expensive, okay, it's expensive because there are more steps than the ones that we have spoke about in order to remove everything other than the water, okay? We don't care about that in drinking water so much, just so long as it's safe for us to drink. Okay, so distilled water obviously means that in order to produce it, we have distilled it. Okay, you probably should have studied that before. You know what distillation means. It's basically when you heat something up until it boils, and then you condense it or you cool it to collect the liquid again. It's a way of separating substances. Okay, right. So I'm going to stop there. That's quite a lot of information in a short space of time. So I hope that has helped clear up how we purify water. If you think about this flow diagram, okay, goes on for a long time. Let's just zoom out here so you can see more of it. It goes on. There are a lot of steps. And remember, we said that if water comes out of a borehole, so from a borehole, we can start at step 5. We don't need all of this because nature has done it for us, okay? These steps are as a result of water coming from rivers and reservoirs, which are of course the most common, and that's why you need to know them. Okay, so I hope that has cleared it up. If you do have any questions though still, please feel free to write a comment or send me an email using the link below. Please remember to like and subscribe as usual, because I've got more videos coming up very soon. But thank you for watching. I look forward to seeing you in the next one.